Honestly, it's the hallway track. Like, the spaces where I've learned the most at CppCon have been in the evenings, hanging out with people over a drink or at dinner and just chatting.
So hi everyone. Thank you for being here today. I let the last people come over. Oh, good. I have a clock here. That's perfect because I tend to sometimes lose track of time. But it's really great to have you here, to have you all here, and welcome to the metaverse. Woo! Oh, Section, how are you doing? I mentioned you in today's talk by Herb. I'll tell you later. So first of all, really welcome for you to be here today. How many of you knows what the title reference to? Metaverse. How many of you know what the title is referencing to? Keep your hands up. Oh, okay. Oh, okay, that's not bad. I should have picked a better title, I've been told. How many of you read the abstract? Or how many of you know that you're here for a talk on reflection? Just want to make, okay. Thank you. Okay, so first of all, I apologize for the title. It looks like, I should have probably not tried to be so clever. So, Meta is the new namespace that we're going to add for reflections to Meta. And I'm going to talk more about this, of course. And welcome. So, I'm sure you can guess that this picture was generated by AI. It's just because I used to draw, but I don't have time for this now because I'm a C++ developer. But honestly, I miss that. So instead, I went to AI. But I'm just trying to express here the world of possibilities that I see as what reflection is. So I hope this picture helps. A bit about me. My name is Inbal Levi. I don't know if you've met me here already, or we talked. If we haven't, please come and talk to me. But I'm a C++ software engineer. I'm working on OS internals in Microsoft as of around a year ago. I'm also an ISO C++ Foundation member. The C++ Foundation is the one behind this conference, which is pretty awesome. And Boost Foundation board member. I'm sure you all heard about Beeman by now, hopefully. Yay! Yeah, we have a person here in the front with a t-shirt. Oh, the logo is amazing, by the way. I don't know who did this logo, but it's an amazing logo. I'm also a member of the ISO C++ committee as Israeli National Body Chair and as Library Evolution Workgroup Chair. So Library Evolution, for those of you who doesn't know, is the group that is in charge of the features that go into the standard library. It's in charge of the design of the features. So we have another group after us that is in charge of the wording, because I'm sure you all already heard or know that standard proposals go by, you have some implementation reference, you have some design, and you have wording, because the wording is actually what puts that into the standard. Cool. So yeah, so here's also a small photo of what the standard looks like. And you can see here, let's see if it works. Oh, cool. So you can see, here, SG7 Reflection, which is the domain group for reflection, the one that's been incubating this, chaired by Hannah Desokova. Thank you so much to her. And you can see here the two groups above, core evolution and library evolution. This is the language group and this is the library group that have been incubating this proposal. So I already tell you that this was one of the largest proposals we had, definitely for 26 of maybe ever. And it had two parts. It had library aspects, and it had language aspects, and it had library aspects. And we're going to review this as well. So just one more call out. I hope that I didn't miss any other reflection talk. If I have, I am sorry deeply. But we had two talks in this conference already. One by Barry Razvin, which is one of the authors. I will also bring his name a lot during the presentation. He is one of the drivers of this proposal, which is really awesome. And he gave some really cool examples. And the second talk from this morning by Herb Sutter, about reflection, C++ Naked defining Rocket Engine, and I do agree with Herb that this is groundbreaking feature. So Herb have shown a very, very exciting things that gonna come up, I hope, in the future for reflection. I'm gonna go a bit simpler and broader, because my aim for you today is to understand reflection to like as thorough as possible, so that when you go out there and write code, you'll be able to understand the errors and the problems that you stumble across. So that's my goal for today, not like Herb to define the future or like Barry to show you complex examples. But welcome to my talk. So that's kind of funny because, okay, so anyway, what do I mean when I say reflection? Reflection is the ability of a software to expose its data structure. I think Herb said something very similar. But I also want to emphasize that we're talking here about static reflection. So who exposes this structure? It's the compiler, and it's doing it on compile time. Now, may sound trivial, but this is going to come up later, and there's going to be some riddles, so keep this in mind. And a few disclaimer, it's possible to carry the data into runtime. So basically, if I have something and the compiler generates struct, have this information, I could technically leave it in the binary, but this is not what been proposed for C++26. This is what we're going to talk about here today. And it also may introduce security and other issues, and this is not the focus of the C++26 reflection proposal. But what we do going to talk about today, so we're going to see some intro to reflection. We're going to talk about a brief history of how we got to today. We're going to talk about latest proposal, P2996. This is the one that's been voted in Sofia, not that long ago. We're going to see some usage examples. And as I mentioned before, as I'm Library Evolution Chair, my focus and my interest is on libraries that based on reflections. In the second part, we're going to talk about some impact on our code bases. So we're going to broaden our perspective and look at how is this going to impact our code bases, pipeline generation, and what next. So, oh yeah, one more comment that I wanted to make. We have few implementations already in Godbolt, which is really exciting. One of them driven by Don Katz. He was from Bloomberg, now he's in Adobe. Thank you so much for Don for doing this. And another one is by David van der Woede in EDG. And by the way, by Wyatt Charles also during his time on Log3 also started this implementation. So I'm really grateful for all of them. So let's look at a brief history. The first place that I found that mentions anything that have something to do with reflection in relation to the standard was 2006. But this was a template-based reflection library that Matusz Kolczyk was also getting gratitude in Herb's talk, started working on. And it was called Mirror Reflection Library. This reflection library was something that you might be familiar with as template metaprogramming today, right? We also had some mentions of use cases for compile time reflection by Mike Bartus. I believe that was very insightful to look into the future. And some of the use cases being brought up back then, even before we had the syntax that we have today, were serialization, delegates, getters and setters, and customization points. I will give you another hint. One of those things is not, I guess, in a sense, one of those things we still haven't delivered. So you look at those things and try to think during the talk which of them has not been, I guess, simply delivered, or at least trivially delivered. So as I mentioned, Matusz Kolczyk's library, he was trying to propose it into the standard, and I'm sure you all know that proposing something into the standard takes some time. He's been working on this, but as I said, there were different issues that came from the fact that this thing relies on template metaprogramming. And another approval of that was by Boost HANA, a library that was implemented by Louis Dion, also trying to observe the code. And at that point, we realized that template metaprogramming is problematic for reflection. Anyone wants to shout out why? What's the problem with template metaprogramming? You can also raise your hand if you really want to. Yeah, Saksha, no, you know what? Wait, you know that. Let's go with Richard. Right? And Saksham, you were going to say compile times. Yeah, because Saksham is, by the way, one of the reflections experts that we have here. So feel free to talk to him. Definitely compile time. So that was an issue, and therefore we diverged. Sorry, I'm not a native English speaker, so sometimes I'm going to say things weirdly. So if I do, please feel free to stop me and correct me. We diverged into having a proposed syntax. Because if we can't do this with templates, that means that we need syntax in the language. So as you can see, there were multiple proposals coming up trying to define this syntax, and by multiple people that I'm not going to read their names, but all of them are in charge of what we have today. And at that point also came the question of meta objects. So how would you represent, I have a C++ program, right? This is, let's say, whenever I try to represent something from the real world, how would you represent something from the real world? So the most classical example, students, just shout out, like, how would your program look like? What? A lot of metadata. Metadata, I guess, yes. But where would you save this metadata? Yes, classes. Right. Because our go-to thing when we try to represent things in the real world, which is most commonly what we try to do when we write programs, is classes. So yes, this is exactly what this is. Meta objects are basically objects that represents parts of your program in classes. I would also want to talk, I missed this very important point of saying that Bjarne started taking interest in this, or maybe he started taking interest before, but definitely published a paper, which means that the interest is increasing. David Senkel also published Reflection TS, again, in charge of a lot of the syntax that we have today. So I want to go back to what I said before. So we represent parts of our program in classes, right? So I have a variable and I have a type. How would you put them in classes? Someone just describe me. How would you write a program for that? If I have a small program, it's int a equals 42. I want to represent the parts of this program. How would you write a program to represent the parts of this program? It's not a trick question. A very trivial one. Syntax tree or something? Yeah, that's good. So you would basically do a hierarchy, right? Something along those lines. Okay, so you have the type, int, you have variable a. What would you do with them? Would you put them in different classes? Templates, what? Exactly. Thank you. Someone took the bait. Thank you, person from the front row. Yes, you would. I would, if I would think of a program that I want to represent, I would probably do a hierarchy with a type int, and the type will have different values, int or something else, and they'll probably inherit from that. But that is not what we went for. We went for what we call a monotype design. And what does it mean, a monotype design? So stud Metainfo, that we're going to talk about later, is a single type, represents all the elements in your program by value. I mean, keeps values, right? To represent all the elements of your program. Anyone want to guess why is that? Go ahead, person in the front row. Interesting. Okay, that's a really interesting answer that I have actually not thought of. What's your name, by the way? Ville? Vine. Thank you, Vine. That's a very refreshing perspective. Well, technically we could extend this tree of hierarchy, but you're right, that would definitely create some burden for standardizing for each new feature. Oh, yeah, sorry. I'm very tired because I have a jet lag. So Vine have said that if we have a hierarchy of those different things to represent our program, every time we add a new feature, we need to modify our hierarchy tree, right? We need a new type. This is kind of an implementation burden, and opposed to having a single type, stud Metainfo, that contains values. Agreed? whenever we add type, we need to, now maybe we have functions to deal with this type, maybe we have overload resolution. This is a lot of burden comparing to a single type with a value. But another reason was the compiler implementers suggested that that would be simply too heavy. So we already talked about compile times. Having a hierarchy of types is more heavy in terms of implementation. And I'm not a compiler implementer, but according to them, that was another issue. That's why we went with Metainfo. But actually, after watching Barry's talk for Monday, I think, I think I actually have another really good reason for having Metainfo, because a single type. Because in a sense, reflection now, when we have a single type, allows us to have a heterogeneous design of, like, the algorithms are the same, but for multiple types. All of those types or things or whatever are represented by the Metainfo. So in the realm of reflection, they're all the same thing. So the algorithm that we develop is actually applying to all of them, which is quite cool. So, so before watching Barry's talk, I did not thought of this as another benefit or another positive aspect, but I do think of it now. Any other questions? Any questions so far, by the way? I'm just rambling here. Cool. All right. So yeah, so another thing I wanted to bring up is const experness. So we did have const exper getting into the language. And some people have claimed things like we can have everything as const exper and all the logic, and then we kind of don't need new syntax. But clearly, observing what const exper can do, etc., we did not see const exper as a complete solution, and I will show you more in the future. But we do have more const exper things as a result of the reflection proposal. So naming, as always, naming is hard, syntax is hard, but we've solved all of that. And again, the question of single object, single type versus multiple types came up latest in 2022, which is very late comparing to a proposal that have been, or an idea that have been there for a while. But then we reconfirmed the fact that we want a single type object. And 2023, we got the proposal that we got for C++26 standard, which is P2996, reflection for C++26, which is very exciting. All the names are here. We had some very interesting proposal about Python binding, using reflections and JavaScript binding. You can also see Adam Jagrut, Dankast. Jagrut is here, by the way, in the conference. Saksham also wrote a very interesting proposal talking about how to use reflection for ABI tagging or versioning. And all of those things came after the proposal in 2023 came to try to emphasize and explain what are the use cases of reflection. I think those are very fascinating. So we're now 2 years later, and I'm going to show you the final version of reflection as we got this into C++26. So draft have not been officially signed, but this was voted into the standard, which means that it's very likely that this would be the final form. So I want to show you a quick example to get the thing started. So I have here a library type. It inherits from two base classes, and I have the user code. And I want, in the user code, to observe this type. And basically, I basically want to ask a question about this type. So I have here, first of all, Metainfo. I've mentioned before, this thing represents a reflection expression. And then I have a reflection expression, and then I lift the lib type into the reflection realm. And that's going to be a reoccurring term during this talk. Because what we actually do when we write reflection is we write code in a different level. We basically observe our programs and we lift the things in our program into the reflection realm, get an expression that represents those things, and then query on them. So I think it's a very, very important point to notice. And then I take my reflection expression and I can execute functions on it. Those functions are coming from StudMeta namespace, right? So for example, basis of. So I now query basis of reflect expression and place 0. And what am I going to get? You know that. That's easy. Yes, base one. So yeah, so we're gonna get the thing by the order of declaration, which is also not trivial, right? Pretty cool.
What do you get?
Base one.
What is it a type? Is it a tag?
It's a.
It's the same type. Okay.
Yeah. Yes. Exactly. Thank you. Sorry. Okay. So. Yeah, that was a spoiler alert. So I'm now going to show you all the objects of the reflection proposal, all the components of the reflection proposal. There are a lot of them. So we start with reflection operator. This is going to be splicers, stud Metainfo object that I talked about, and bunch of metafunctions. We're not going to go over all of those, but they exist there. And if you look at them, you'll see things that might resemble type traits. So you might have seen things like is pure virtual, is all right, those kind of things. And this is not coincidence. We actually have an additional version of the traits in the stud meta namespace that use compiler magic, that are basically more powerful for reflection. So that is not accidental. This talk also had different versions. Let's see. Ooh, okay. So I've updated this according to the version. So if you look at the previous version of this talk, those things were modified. So I just wanted to highlight them. We've been modifying some names. But yeah, I'm not going to go into this. But if you look at the slides later, you can see the difference. So let's start. I already showed you an example. First of all, I wanted to say the reflection operator, now double caret, used to be a single caret. Unfortunately, due to clash with language that I will not repeat name here, we had to give up on this syntax, which is very unfortunate in my mind. But now we have the double caret. It's also AKA known as unibrow. So feel free to use this. This is not an official term. This term was not defined by me, but it was defined by JF, which is evolution chair. So I showed you before the groups. That's the nickname that we give it. So yes, we are now familiar with the lift operator. And what does the lift operator do? It shifts things into the meta, it shifts from the program realm into reflection realm. It shifts into meta. So object can be used as input for other reflection utilities, as we saw before. But what happened? Sorry about that. What happened? What about this code? Does this code gonna compile?
It's not processed.
Yeah, you have to, like, that's not fair. Yes, for people that have seen the presentation before, yes, we're gonna get an error. This doesn't work because meta type variables must be const expert. We're talking about something that the compiler is doing. So compiler have to be able to hold this thing. So this is one point that you might gonna get errors in your compilers and start to get frustrated. Think about this. Second thing is the splicers. So we already lifted something into the reflection realm. We have int here, we lifted it. What is int, by the way, in our C++ programming language? Yes, it's a type. Okay, cool. So what would be this thing here? A. You get it? Yeah, you have a there's a hint here. Yes, this is A. The reason I'm using type name is because in some scopes, in some areas of the program, this might be ambiguous. So we can basically, you could do just the splicers here and define like that reflect expression A equal 42, that would get back as a type. But in some areas of the program, like for example, if the name might be ambiguous with namespace or something else, you need to use type name in order to disambiguate for the compiler. Cool, but the default is you don't have to. Yes, so we now have declared A, right, with a type int. But we don't write int here, we write reflection expression. Now imagine this thing is not 2 lines of code, but is a different program passing you something that you don't know what this something is, but you want to instantiate it. You could do it like that because the type that it's being passed here is stud Metainfo. So you'd have a function that takes stud Metainfo, another program, for example, when I say program, I mean another code, another whatever. Yeah, one second, let me just finish my sentence. In another code initialize this reflection expression, but you don't know what the reflection expression represents as a type, but you want to create one of these. So I do hand waves here because obviously I initialize it, and if it was something that doesn't fit to be initialized with 42, it will be a compiler or other things, but I do want you to understand the power of this. Yes, Richard?
So then, if I understand this correctly, so we're saying rexpar
Is an expression.
is an expression, and I could,
Stud Metainfo, in fact.
yeah, and I could pass it to another function for it to use. I would imagine the function has to be const_expr at that.
Yeah. It does. It also have to be const eval.
Does it matter if I pass it by reference, R value, pointer, const,
Let's get back to
volatile?
that.
Okay.
Because it's an interesting question. Yes. I would say by default pass it by value. Yeah, but we will talk about this because it's an interesting question. Yes. Sorry, what's your name?
Enrique.
Enrique?
Yes.
Go ahead.
Is it legal to put unibrow inside a splicer directly?
Yes, it is. Enrico have asked, is it legal to pass? Thank you, volunteer, for marking me to repeat the question. That is very, very useful. As I said, volunteers are very, very useful. Thank you. I really do appreciate it. Yes, it's legal. You could. This is a regular C++ syntax. If whatever you can do that kind of makes sense, take this expression and put it somewhere else, it will work. This is what Herb has tried to emphasize as well. This is regular C++ syntax, so all the rules you're familiar with are also applied here. For example, could I write this inside of a class like body? Really? Think about it a bit. Okay, true. But we'll get back to that. Okay, so splice exact, I was just trying to mess with you. So splice extract the C++ expression back from the stud Metainfo. But then we can use this in a C++ program. So again, just to emphasize, we have our expression. What is this thing? You can shout. Metainfo object contains info of int. What is type name expression name? Yes. Isn't it? Cool. You now know reflection really, really well. So now when you're going to get errors, you're going to be able to identify them. But I do mean it. Oh, the rest is functions, and you know how function works. So we talked about lift operator and about splicers. Let's talk a bit about the stud Metainfo object type. Who recognized this? What is this? Anyone worked on compilers here before? It's a hint. Raise your hands. Yes, that is true. Thank you for, sorry, I forgot your name. Max, thank you for the 5 experts that I have in the room. But thank you for keeping the presentation going. Yes, that is true. Max has correctly identified this AST. Can you recognize which compiler this AST is from, by any chance? It's small, so I wouldn't it's understandable if you can't. Yes, that's a Clang AST. Cool. So yeah, that's the Clang AST of this function here. Oh, I just realized this is quite dark. I'm sorry about that. Okay, I hope that wasn't too much of an issue in the previous slides. Yeah, that's the Clang AST. So we have here things like function declaration for the function on the side, right? Int, main. We have variable declaration. We have I. We have int, etc., etc. We even have the L value, R value definition of this. So yeah, this is not by coincidence. Stud Metainfo represents. Stud Metainfo can be as equivalent of AST node. So it basically, we don't, in the standard, we don't specify implementation. So we can't tell implementers how to implement, but I would not be surprised if they put this as a reference to their AST. So keep that also in mind. So type and type aliases, function and member functions, basically all the different things in your program, enumerators, templates, namespaces, etc. Look at this last line, expression sorry for the width, that can only be evaluated at compile time. So there's a restriction. Stud Metainfo have to be const eval. So yay, now you know reflection really well. I'm not going to give you any hints. This code compiles. One second for the question. Does this code compiles? Yeah. Okay. Yeah. Yeah. Obviously, if I'm asking, but yeah, yes. You already know the answer. This does not. We don't have const expr. So what about this int? I don't know if you remember in the example. I don't want to slide back. In the example I showed you before, it was const expr int a, and then the reflection operator. Sorry, it was const expr reflection operator reflects int lift operator int. And it was const expr, and then the second expression was also const expr. I have here int array. This is not const expr, const eval thing. Why does this thing works? Yes, exactly. So yes, it's confusing, right? Because I declare something that is not on compile time, but I still able to query the object of this thing. So reflect object, I will give you the information. It takes an expression, but this expression in normal program, what would this R, sorry, that's actually a bug. R0 will evaluate to.
Well, R1 will also evaluate
Yeah,
to the end reference.
no.
Isn't
I
it?
probably did a syntax error, but yeah, it's
It's a reference to int?
it's zero. It's zero. You access this element in the array. It's zero. It's not initialized, assuming garbage put aside, etc. But I can still reflect on this thing and get the type, right? So this is not compile time thing, but I can still get information from this. For example, what its type is. Yes, Richard.
But the result of a bracket operator is, the type is an in reference. Like if you have, because you can assign to it, right? So it's not an R value int, it's an L value it's an L value reference, isn't it? Because if I have a bracket operator, I can say.
It doesn't matter because if you'd write this in a program, it will be evaluated. So by the time I get to the parentheses, it is some int, in this case, let's say 0.
So I guess
it doesn't really, R value and L value are not in play in this.
Is reflected object getting the type of the expression or the result of the expression?
It gets the type of the expression, and that's exactly the interesting thing here. That's why I'm showing you this function. Yes, sorry? Vinay, yes, go ahead, but then I want to continue, and it's not a tricky example. I was only showing you the reflect object usage. Yes, so don't try to kind of realize this is just a regular array. Yes.
So my question is really similar.
Yeah. Mm-hmm.
Usually when you run const expl code, it can catch undefined behavior when you try to access something that is not initialized. So
Yeah. Okay. Please ignore the fact that I did not initialize this array. Please ignore the fact that I've accidentally put here 1 when I intended 0. Please ignore all of those. It's just a regular array with 1 element, and I'm sorry for editing this and not paying attention. Yes. What's your name? Sorry. No, the person in the back. Tom. Yeah. Yes, Tom.
So you, sorry.
Yes.
But you have all this list of the things Metainfo could represent.
Right.
And you had all these functions before.
Right.
Calls Metainfo. But one downside of having a single type is that not all functions really are applicable to all of these different things, right?
That is true, and we have a mechanism to report errors.
Yeah, that's
And I will get to
what
it.
does it look like?
Yeah. I will get to it. You're correct. Let's continue. All right. So stud Metainfo. I have another. I said there's gonna be questions and riddles during this talk. So I have another riddle for you, but unfortunately it's very dark. Okay, no, it's gonna work. Cool. I have a class R, just a regular class. Nothing here too complicated. I have a stud Metainfo result expression that represents this R. And I have a print, and I basically ask about this class is complete type. So anyone here doesn't know what is complete type is? What is a complete type? Okay. What? Sorry?
It's fully defined. Or it's,
Yeah, exactly.
it's defined when it's visible.
Yeah. Let's just say When I declare this R, the compiler doesn't know how to instantiate this thing until I tell it what this R looks like. So at that point, it's not a complete type, right? So what do you expect this this function, meta function, is complete type to return? Yes, false, true, at that point. Now I completed the type, right? I have here, so just to emphasize, the name of the expression here is res1, okay? That is important. I've completed the type, and now I ask this question again, and I declare this res2, and I ask the question is complete type, and then I save this into print2, and then I ask the same question on res1 again, save it into print3. So now, I have a question for you. What will be printed? So the first is false. I already gave you that one. Wait. The first is false. Please, everyone. I know it's late. I know it's the end of the day. I'm giving you the first. The first is false. So we have 3 prints, false, either true or false, and either true or false. So who thinks, yeah, go ahead, say the answers that you think. False, true. So, okay, so how many of you think false, true, true? Raise your hand. That is Max in the back. There's a few people here. Cool. Interesting. How many of you think false, true, false? Cool. I'm sorry, I'm really enjoying this. So I thought, like you all, I expected false, true, false. What did I get? False, true, true. Why did I get false, true, true? What is happening here? I gave you already the hint. I actually said that. Anyone remember what the std Metainfo kind of goes to by default implementation? AST. What happens in AST? AST represents our program, but it's been updated during the reading of our program. So res1 here, despite the fact that we basically took it, despite the fact that we took it up, terrible, up here is actually, looks like a value type, right? That kind of addresses your question, Richard. But what is this thing? It's actually kind of a reference type to the AST. So yeah. So it's not, okay, that's a good question. Let me think. I'm trying to think. Yeah. So it was a question, is that an implementation defined? So in other words, is that actually specified in the standard? So I can tell you that we actually specified in the standard, yes. So in a sense, we specified in the standard that reflection is a stateful, which means, we didn't exactly write it this way, but stateful means, in opposed to stateless, that you have res1 and its states get updated. And I may have confused that because I'm very tired. But you got my point. Yes, it's not defined whether, for example, this expression will return true or false, but it is defined how reflection would behave. And second point that I want to make, putting aside the specification, is that all implementations would behave this way. And this was actually pushed back from implementers because what would you need to do in order to have res1 return false on the last, go ahead, Richard. What would you need to do? Assuming you're a compiler implementer.
You have to like snapshot your...
Yes, exactly. You have to snapshot, you have to store, you have to kind of save something, you increase the footprint of your implementation, and people were not happy, so that's what we got. So I will say I'm not super happy, but I also accept and understand why, and that's an interesting thing to recognize. So whenever you write programs, and oh, by the way, you could save, of course, you could store the result of the, like print1 still stores the result, right? What I was asking about is the evaluation of rest. So pay attention, this is a bit subtle. Yes, Richard, but I really need to move forward.
So what's the implication for this of putting in header files where at some points in your program, you forward declared a lot of classes and then you fully declared classes? Like, doesn't this mean...
Exactly what you see here. This could be, you could cut this part into a header file. Oh yeah, sorry. Richard was. Thank you, thank you. What's your name, person? Nice person. Again? Pablos. Pablos. Sorry, whatever. Thank you so much. Please come back. All the volunteers, please come to the stage afterwards because I want to thank you properly. Anyway, yes, this part is, you could wrap this thing into a header. It's basically what you see here. So if you ask this question earlier, before you, exactly that. Cool, and by the way, I maybe forgot to mention, there's QR codes, there's Godbot links, go and play with those stuff. So we talked about reflection operator, the lift operator, splicers, student Metainfo, and how does it behaves. We're now gonna go over each and every one of those metafunctions. Not really. Sorry, yeah, not each of every one, but there are tons of metafunctions. They're really cool. You should go and check that out, and hopefully they'll be in CPP reference soon, or maybe already are. There's another thing that came in late, the const eval block. It's exactly how you imagine it. It's a const eval that you can open parentheses, write stuff, and close parentheses, and it'll be const eval. But I don't go there because it's, first of all, it's a late proposal that was appended upon, and second, I don't have time. So please look into the paper number if you want. So metafunctions, I already showed you a few of them. I want to show you one more here. I have a equal 42. I have meta name of. You're already familiar with all that. What do you expect to be printed for this a? A, interesting. How about if I'll put this in a namespace? Now what? Still A. Okay, so names in C++ are ambiguous because do I want a fully qualified name? Do I want... So instead of name of, we replace this to identifier of. There's another function that's called the, I forgot the name. The designate, yes, thank you. So name is not good, ambiguous. However, when I write logs and things like that, I maybe do want to have some more fine-grained control of this. We may extend this later, but for now, you get the identifier. Identifier is the simplest identifier thing in the closest scope. But this is an interesting point, right? If I want to keep this in mind for logs. So all the metafunctions except info and return, except for some metafunctions that reflect value object and function that accepts the T, except info and return either string view or stud Metainfo, another stud Metainfo because you did something to the type, right? Or a vector of stud Metainfo, for example, we saw this in basis of, or a Boolean size t, and source location and member offset, which is a new struct that we added in order to query bit set and stuff like that. The return of offset of. Cool, so you're now familiar with basically the majority of the reflection proposals, so you can now pull those Godbolt links and play with them. I want to show you two more complicated functions. I do have kind of have time, so I'll do it very quickly. Okay, so substitute. Substitute is the equivalent in reflection realm for instantiating a template. So I have here an array. Sorry, I don't know why it jumped, but yes, sorry about that. Okay, let's just start here. I have here an array. Okay, yes, sorry about that. Let me, what was I trying to show here? Okay. Reflect expression here is the result of substitute function. Substitute function takes array, std array, and takes int and, the stud meta info object that represents an int and reflect value of 3. So reflect value, I'll give you a hint, is like taking value from your program and again, throwing this into the reflection realm. So wherever I want to put 3 in my real program, I'll put reflect value of 3. So anyone wants to guess what this function is basically doing, this substitute function? Takes array, takes type, takes value, which is 3. Exactly, it's instantiating a template. Now I have another question. Where does it instantiate the template? Is it here? That's a hint. Oh, I'm so sorry. Okay, there's a call for substitute, and it returns something, and there's we splice the expression. Thank you so much. Sorry, did that help? We splice the expression that was returned from substitute, and call my array 1.
When it's spliced.
Spliced is this operator that I've shown you before that basically takes things back from this thing is a stud meta info object. So the result of substitute is stud meta info object, and here I splice it back into our real program world. Yes, thank you. Who said that? All of you. Oh my God, this is a group of very smart people. Why do you think that, by the way? It costs, right? It costs. So yes, here what I do at line 1 is basically I just hold a stud meta info object that represents something that when I send it back to the program world is a type. So only here I actually get the call. What you used to look at array int 3 is that. And this is just preserving. It's preserving the information so that later, okay, so substitute returns something which preserves the information so that later you can create the type. So yes, this is tricky. It's only later instantiated, which is pretty cool. It's delayed, it's useful, it's effective. Here another example. I have here some structs, and this struct takes an int, and imagine that this is just declaration of struct s, : What would happen here? I substitute, right? And I'm not going to show you the next thing. It's good because it's actually have the comment on showing what it shows. So I'm actually utilizing the fact that you don't see what's going to happen next. What's going to happen when I try to splice this?
I guess by what you said that the splice would be okay, but then the instantiation would fail.
No. The splice is the... Okay.
I'm sorry. The substitute would pass.
Exactly that what would happen. Thank you. This is awesome. Sorry, what's your name?
Jay.
Jay have said the substitute would succeed, the instantiation would fail. Cool, all right, awesome. Another edge cases. So now we're talking about extract. I would, if you have questions, I know it's very interesting and cool. We have about 12 minutes and I do want to go over a lot of things. So try to keep your questions to the end and I'll try to take a few of them. And if not, please catch me on the break. So extract, what does extract do? It's the equivalent in reflection realm for extracting values. So again, I'm sorry about the weird animation. I have here expression, extract int, and reflect value 3. So what would happen here? Extract. What is this? Type.
Int.
Right, it's int. So what do? I tell extract that, and you can notice that this is a template function, that I take an int, and there's a reflect value 3 here. What this thing returns. Stud meta info object represent 3. What would happen on the next example? I have expression and I extract, sorry, oh, that's better. Sorry about that. Animation was a bit weird. Second line, and you can already see the answer. Fails, right? Why does it fail? Because I can't extract 3 from a string. So extract, I think Barry said it really well. It's just like any cast, just like extracting value from a cast. So basically, you can extract by giving the type from stud meta info object the thing that you want to extract from, and you're going to get back the type. Cool. Continuing, type traits I already talked about, so I'm going to skip this. I want to talk, I don't have a lot of time, I have 10 minutes. I want to talk about function param names very quickly, and then I'm going to move to other topics that I had in mind. So I have a function here, print param k, okay? and it takes a stud Metainfo R and a size T of params, and it basically returned the name of parameters of R in the location K. So imagine now that R is basically a function. So I give it a function, and I'm asking, give me back the name of all the parameters. That's the gist of it. So I now have a function, func, with int first and int last, and I have another, that's the function declaration, and then I have the function definition. Function definition is int n, int ln, I think I called it here. What would be returned from the function that I showed you before that basically takes a function and prints its param names? So just a reminder, I have, so sorry about that. I have int n, int ln, and in the function declaration, I have first and last. Yeah, you don't know, right? Why do you not know? Because it's not like well defined. It's not, we don't have any rules in C++ that tells you what this thing needs to return, because there's no canonical name for func params, right? So if I have a declaration and definition, there's no canonical name for those things. That means that we need to make a decision here, right? So we could do multiple things. We could say we go with the last the last names that we see, which is in this case would be n and ln. We can decide that we go with some weird array of all the names that this int had. We could decide that if this thing doesn't have the same name, we fail to compile. We could decide a bunch of things. Because I don't have a lot of time, I will introduce you to all the options that we can have. So there's tons of other options, but what we had when we discussed this in the committee, and we discussed this exact thing in the committee in library evolution, because this is a library function, right? It's a library function. There's equivalent library function, doesn't matter, inside of reflection, that takes a function and needs to return its param names. So we had multiple options. We have compile. No one knows what returns. So if I had clang, like it's implementation defined, in other words, if I have clang and I compile it in clang, I get one answer. I compile it in GCC, I get another answer. I can enforce consistent naming, which means that if I have different names, I do not compile. Or I can maybe mark with an attribute some of those declarations, definition, whatever, and say this one's the canonical one. I care about this one. I see oversimplifies. There are other options. 3 options. If you would have sit in the room, what would you have voted? Who would have voted for compiling no guarantees? Application would be that if you have a log file from one compiler and you try to fit it into a different compiler, it doesn't fit. Who would vote for the first one? Okay, not many people. Who would vote for the second one? Enforce consistent naming, which means fail. Okay, cool. Who would vote for marking by attributes? Okay, cool. Well, I kind of like marking by attribute, but what we went with is actually enforce consistent naming. So it have implications, right? Someone want to think about the implication of this thing. Yes, it breaks. Yes, Tom is saying you can't introduce reflection to existing code that violate this rule. But no one ever told you that you have to use the same names in definition declaration. In fact, some companies prefer not to for different reasons. Some companies have the declaration with no names and then the definition with names, and that's a valid use case. So, but we went with this. I think I can talk to you about this later, but I think this decision was actually a good one, considering, but it still have implications. So unfortunately, it keeps happening to me. I do not have time to talk about reflection logger example. So please look into the example here afterwards. It would do exactly what you would imagine, but with all the tools that we saw, go ahead. With all the tools that you saw today, and I trust you all to be able to one more addition that you can actually report context where value is kind of a utility that is also only in EDG, that is not standardized, that allows you to basically print from the compile time. By the way, one more thing I want to mention, JetBrains have IDE that debugs compile time as of a few days ago, which is super awesome. Now that we have reflection, we really need this thing, right? How exciting is that? Okay, cool. So I'm gonna skip this one as well, unfortunately. I will just say in a few words, I have a talk about customization points. Reflection was considered as a customization point option. My personal opinion is that you don't want to use reflection as customization, but customization point is how you basically modify your library to fit to your user types if you want to have like specialized behavior. I don't think that reflection fits that because it's quite complicated, but it could be used for that. So in my personal opinion, we should have more customization points, but reflection allows you to do that, but in a complicated way. So jumping forward, the example I talked to you about before, and you identified correctly, is breaking user code. So if I so far had my pipeline, and I had compiled something into a library, and I linked it with my main, and I found out on linker that I have a problem, maybe, and I could do version controls with macros and things like that in the source code. Now, because reflection breaks existing code, I would not get to the linker. I would stop in the compiler, I would get errors. And that, for example, imagine I work in a company, I write logger library. My logger library works perfectly well on most of the code, but someone from the other team takes my logger library, which is written in reflection. And this is just like template metaprogramming, by the way. This is like just like template header, right? In the sense that it needs to see the source code during compilation. But I take it, I give it to another team, and they can't use my logger library because they don't have this this restriction applied in their code. Or maybe they need to now modify all the names. Fine, so that's something to think about. Okay, I have 3 minutes. I have a bit more things to talk about, and I'm very excited, by the way, for all of your questions. So instead of showing you all the slide, I will tell you that. I had some consideration whether do we even need reflection, which is code generation, considering the world of AI. So I have an agent, I have AI. I ask, in this particular example, I generate a parser. I can give it a code and ask for code generation. Why do I need reflection for if I could just do this by AI? It's an interesting question, right? How many of you think that we still need reflection? Wow, awesome. I want to talk to you all afterward. How many of you think that we don't need reflection anymore in the world of AI? Okay, well, I agree with you all that we still need reflection. I cannot promise what will be in the future, but for now, I do agree with you. And I can give you one very, very strong reason, is because the output coming from AI is not consistent. And when I use reflection feature, I know for a fact that what I'm going to get, each iteration of running this is consistent. So not going into the weird things that the AI generated, which I wanted to show you all here, it's inconsistent. Second thing I wanted to talk about is Rust. So it was brought up in a panel. Rust does have utility of reflection. It's have procedural macros, which is, I guess, is like you could refer to macros as something that you can think of as equivalent, despite the fact that it doesn't look the same way, it doesn't work the same way because it's actually being observed by the compiler. And they also have the scene library, which is library that inject tokens into the AST. Okay, so you already talked about AST. So we have like the stream of tokens that are your program, and you now need to get into the stream, inject something into the stream in order to reflect, to basically read information. That's what it does basically, and then or generate, and then give back the stream, continue with your program. So I said in the panel, in my opinion, and that's my personal opinion, that's less good of a user interface. Now, could claim that the macros themselves are intuitive and comfortable. So the generation part is actually more intuitive. I think the reflection part, the part that you observe, is less intuitive. That's my personal opinion, but that is an interesting thing to consider. Another thing I wanted to talk about is the errors. We talked about errors. Oh my God, I have no time. We talked about errors. So we have new feature that comes with reflection. This new feature is context pair exceptions. That means your reflection code can throw exceptions that are basically only valid in compile time. Those exceptions cannot leak to runtime, but they provide you a better way to notify the user of the error. So basically like an error message, like you would have used with a regular exception in a regular code. So you can catch them, you can print them. Pretty cool, isn't it? I think it's really cool. What? Try. No, just try catch. And if you evaluate this in a const eval block, that will be const expert. And okay, so this is awesome. So yeah, to answer the question from before, the things that can happen when your reflection fails, and I already mentioned that with the example, is either compiler doesn't compile, or you get const expert exception either been caught and printed, or if not, it will be terminated. The program will be terminated. The compiler will fail. So this is what can happen with reflection. So what should we expect from reflection libraries? I think Herb was actually talking about this really well. I think the realm of libraries, the realm of possible libraries have just opened in front of us. And I'm being in Library Evolution group, Library Evolution chair, I expect to see a bunch of proposals coming our way that were originally meant to go to evolution, to the language. Because now we're going to have so many of you writing code in reflection, code that you can test on your compilers. You don't need to be compilers developers anymore to be able to modify the language. And you're going to write libraries in reflection, and they're going to work and do observation and everything else. And you're going to come to our group and propose this as utilities for the standard. So first of all, I welcome you all, and I have my email in the end, because I'm really, really looking forward to the world of possibilities that we're going to have with this feature. And I need to hire more people to help. So that's it. So I think that's actually summarized my talk. Last thing I wanted to shout out, you already seen, I hope most of you at least saw Daisy's talk about AI. If you want to learn more about AI, I didn't even have time to touch it, but I was trying to. But if you want to learn more, go there. Hannah Desukova, SG7 chair, she also is in charge of a lot of the const expert things that we saw. A lot of the const expert utilities that were added with reflection. So if you catch her at some conference, thank her, because she did so much work. And I'm very excited about having reflection in 26 after, I guess, 20 years or so that we actually looked at this idea and observed it. And last but not least, I want to thank Core CPP user group. That's my local user group in Israel that reviewed this. Hannah Desukova, Matush, David, Corenta, and Luis, Adi, that all gave me feedback on the talk or gave me input on the things that you've seen. And I want to thank all the reflection paper authors and contributors, and I probably missed some of them, but I really, really think that they are in charge of what we got here today. So thank you all for being passionate about C++. Thank you very much. I had to skip the few of the last slides, but you can see the presentation. And most of all, I want you to email me for anything that you have in mind. And if you have new reflection library proposals, please feel free to reach out. I'm excited about this. Thank you.